An unbalanced amperage reading on a three-phase motor can stem from several potential causes. Firstly, loose or damaged electrical connections can lead to higher current draw on one phase due to increased resistance. Ensure the motor's electrical connections are secure and free from damage. Check for any loose wires, terminals, or connectors. Tighten or replace any faulty connections. Secondly, mechanical misalignment between the motor and the driven equipment can introduce additional load on one phase, resulting in a higher current draw. Verify the motor's alignment with the driven equipment. Use a laser alignment tool or other suitable methods to ensure proper alignment. Adjust as necessary. Thirdly, worn or damaged bearings can increase friction and cause uneven current distribution, contributing to amperage imbalance. Listen for any unusual noises or vibrations that may indicate bearing failure. If necessary, remove the motor and inspect the bearings for wear or damage. Fourthly, a faulty motor winding can cause imbalances in current flow between the phases. This could be due to a short circuit, an open circuit, or an uneven distribution of windings. Perform an insulation resistance test, often called a mega test, on the motor's windings to identify any potential faults. Fifthly, a ground fault can occur when electrical current escapes from the motor through its enclosure to the ground, potentially leading to higher current draw on the grounded phase. Use a mega or insulation tester to check for any ground faults between the motor's windings and the frame. Sixthly, abnormal voltage, such as unbalanced or low voltage, can cause irregular current distribution. Measure the supply voltage using a voltmeter to ensure it is balanced and within the motor's specified range. To systematically troubleshoot this issue, follow these steps. 1. Inspect all electrical connections. Visually check the motor's electrical connections for any signs of loose or damaged wires, terminals, or connectors. Tighten or replace any loose connections that you find. 2. Verify mechanical alignment. Use a laser alignment tool or other methods to ensure the motor is properly aligned with the driven equipment. Make adjustments as needed to correct any misalignment. 3. Check the bearings. Listen for any unusual noises or vibrations that may indicate bearing failure. If necessary, remove the motor and inspect the bearings for wear or damage. Replace any worn or damaged bearings. 4. Test the motor windings. Perform an insulation resistance or mega test on the motor's windings to identify any possible faults such as shorts or opens. 5. Inspect for ground faults. Use a mega or insulation tester to check for any ground faults between the motor's windings and the frame. 6. Verify the voltage. Measure the supply voltage using a voltmeter to ensure it is balanced and within the motor's specified range. The difference in amperage readings can sometimes be caused by a combination of these factors. A thorough troubleshooting process is essential to identify the root cause of the imbalance. If the problem persists or worsens, it is recommended to contact a qualified electrician or motor specialist for further assistance. They will have the tools and expertise to diagnose and repair more complex motor issues. Remember to always energize the circuit before performing any electrical testing or repairs to ensure your safety. Observe all applicable safety precautions when working with electrical equipment. The National Electrical Code, or NEC, provides guidelines for electrical installations to ensure safety. While the NEC version in effect at the time of this discussion is the 2008 edition, always refer to the latest edition for the most up-to-date requirements.